I am Mr. Ish and I am welcoming you to this trigonometry problem video. I promise all of you a very beneficial and interesting question. If you have this x and y axis, a Cartesian coordinate plane, you have from the origin a ray which is directing up at that angle at 45 degrees. Then at a specific coordinate point 10, 0, we have another ray which is projecting at a direction of 30 degrees on this side of the horizontal, or if you wanted to be a little bit more specific, you could say 150 degrees. Either way, we have 30 degrees here, we have 45 degrees here, we have two rays which are projecting. You know, if they project towards infinity forever, there's a specific point where they'll intersect. We have to find the intersection point of both these rays where they meet. And this intersection point, you know, is going to be x comma y. We have to determine that x comma y, and how would you go about doing that? It's an interesting question because it will take quite a bit in terms of algebra to solve this, and by quite a bit, that's again a matter of perspective. It would be an interesting question for us to do regardless. If you were to connect this down, you know you've generated two 90-degree angles which share a common height. They both have a same height. If you were to look and determine this height, it could help you quite a bit in terms of the y value, and then you need to somehow determine the x value over here. If you're looking here at a 10, 0, you know you're looking here at a distance 10 units away. If you were to divide this into two separate numbers or separate into two numbers, you're looking at an x and you're looking at a 10 minus x. You've algebraically divided 10 into two separate numbers. If you relate this x and the h and the 10 minus x, you can do so by the tan formula, the tangent formula. For this first triangle, tan 45 is equal to opposite to that angle h divided by adjacent to that angle x. When you look right here for this triangle, if you do tan of 30 degrees, opposite to this angle you have this h, the height, and then adjacent to that you have 10 minus x. And you have everything you need over there to do your determination for the x. Tan 45 is wonderful because tan 45 is always equal to 1. When you cross multiply x over here, you know h is equal to x. So you save that aside because it helps you down the road and not too far away. Tan 30, what is tan 30? Well, if you think about trigonometric ratios, you know you have a 30, 60, 90. You have a 1, 2, root 3. Tan 30 would be 1 over root 3. You don't need to bring this into a decimal form. Keep it into fractional forms. Is equal to h over 10 minus x. Cross multiply here. H is equal to 10 minus x divided by root 3. Here's another equation you have. H is equal to x. H is equal to this. Make them equal to each other. X is equal to 10 minus x over root 3. We've determined this right here. X is equal to all of this. Cross multiply here. Root 3x is equal to 10 minus x. Bring this x on the other side. You will have x plus root 3x is equal to 10. And then you will have, you can do x into 1 plus root 3 is equal to 10. And then you can solve for this x. X is equal to 10 divided by 1 plus root 3. And let me do that here in terms of now decimals. I'll do 1 plus 3 root. I'm going to save this. It's 2.73. I have 2.732, x is equal to 10, then x is equal to 10 divided by that saved value. 10 divided by that saved value, 2.732 will give me 3.66. And now I'm going to bring decimals into the play. 3.66, x is equal to that. If I know x is equal to that, I know what this here is. It's 10 minus that. And just take this value from 10. You have 6.339, which I'll round to 6.34. And we have another value coming here, 6.34. This right here is equal to 3.66. This here, 10 minus x is equal to 6.34. The height based on this specific expression is always equal to x. But x is equal to 3.66. Therefore, this must be equal to 3.66. Remember, this is a 45, 45, 90. It's an isosceles right triangle. This will be the same as that. Hence, the angles are 45, 45. So I know here the height is 3.66. The height corresponds to the y value. I know that. I know here in terms of the x dimension going up, I have a 3.66, comma 3.66, and that answer right there should be right. And you could verify this in all instances. Allow me to show you. You have 3.66, you have 6.34. Do this divided by that, opposite divided by adjacent, inverse tan it, and you should get 30. you'll do 3.66 divided by 6.34 with regards to a specific angle here. Tan x is equal to opposite or the height divided by adjacent. You inverse tan that and you should get 30 degrees, very close to it. You can do 3.66 divided by 3.66 and you'll get 1. You'll inverse tan that, you'll get 45, which is exactly what you want. So the answer here, right here, 3.66 comma 3.66 is right and it's good. Right here at this point here you'll have 3.66 comma 0. 0 comma 0, 3.66 comma 0, 10 comma 0, 3.66 comma 3.66. But the question was find the intersection point of both rays. This intersection point is right over here. 3.66 comma 3.66 and it's completed. So this entire trigonometry problem has been completed for you. Just required a bit of algebra to solve it and then a bit of trigonometry along with that, and it should not have been too hard for us. But this right here is a good example of a question you can see in a slightly more difficult standardized exam which has a focus in trigonometry. And that's it for this particular video. Have a great day. Thank you for watching. Bye.